Today we are going to learn about grid-based methods. Basically, there are two types of grid-based methods. The first one is Sting and the second one is Click. Sting, Statistical Information Grid, is a grid-based clustering technique. It uses a multi-dimensional grid data structure that quantifies space into a finite number of cells. Instead of focusing on data points, it focuses on the value space surrounding the data point. In Sting, the spatial area is divided into rectangular cells and several levels of cells at different resolution levels. High-level cells are divided into several low-level cells. In Sting, statistical information about attributes in each cell, such as mean, maximum, and minimum values, are pre-computed and stored as statistical parameters. These statistical parameters are useful for query processing and other data analysis tasks. This is basically the representation of Sting. The first layer, I-1 layer, and ith layer. The statistical parameter of higher levels cells can easily be computed from the parameters of the lower level cells. How Sting works. Step 1. Determine a layer to begin with. Step 2. For each cell of this layer, it calculates the confidence interval or estimated range of probability that cell is relevant to the query. Step 3. From the interval calculated above, it labels the cell as relevant or not relevant. Step 4. If the layer is bottom layer, go to 0.6. Otherwise, go to 0.5. Step 5. It goes down the hierarchical structure by one level. Go to 0.2 for those cells that form the relevant cell of the higher level. Step 6. If the specification of the query is met, go to 0.8. Otherwise, go to 0.7. Step 7. Retrieve those data that fall into relevant cells and do further processing. Return the result that meets the requirement of the query. Go to 0.9. Step 8. Find the regions of relevant cells. Return those regions that meet the requirement of the query. Go to 0.9. Step 9. Stop or terminate. Advantages of Sting. Grid-based computing is query independent because the statistics stored in each cell represent a summary of the data in the grid cells and are query independent. The grid structure facilitates parallel processing and incremental updates. Disadvantage. The main disadvantages of Sting, as we know, all cluster boundaries are either horizontal or vertical, so no diagonal boundaries are detected. This is all about Sting. Now we are going to learn about Click, an appropriate subspace clustering method. It is a density-based and grid-based subspace clustering algorithm. It discretizes the data space through a grid and estimates the density by counting the number of points in a grid cell. A cluster is a maximal set of connected dense units in a subspace. A unit is dense the fraction of total data points contained in the unit exceed the input model parameter. Subspace clustering. It is a set of neighboring dense cells in an arbitrary subspace. It also discovers some minimal descriptions of the clusters. It automatically identifies subspaces of high dimensional data space that allow better clustering than original space using the a priori principle. Major steps of the Click algorithm. Identify subspaces that contain clusters. Partition of the data space and find the number of points that lie inside each cell of the partition. Identify the subspaces that contain clusters using the a priori principle. Identify clusters. Determine dense units in all subspaces of interest. Determine connected dense units in all the subspaces of interest. Generate minimal description for the cluster. Determine maximal regions that cover a cluster of connected dense units for each cluster. Determine minimal cover for each cluster. Strengths. Automatically find subspaces of the highest dimension as long as high density clusters exist in those subspaces. Insensitive to the order of records in input and does not presume some canonical data distribution. Scales linearly with the size of input and has good scalability as the number of dimensions in the data increases. Simple method and interpretability of the results. Weakness. As in all grid-based clustering approach, the quality of the result crucially depends on the appropriate choice of the number and width of the partition and grid cells.